Welcome to NextGen Manufacturing Nexus, where we dive deep into the tech and processes that are shaping the future of making things. Today, we're tackling one of the absolute cornerstones of quality control, the first article inspection. So, let me ask you a question. What if one tiny, single, overlooked error in a production line ended up costing millions of dollars? Because that's the reality. We're not just talking about a bit of scrap material. We're talking about massive, costly rework, product recalls that can absolutely cripple a company, and worst of all, losing the trust of your customers. It's the kind of problem that keeps quality managers up at night. So, how do you stop it before it starts? Well, the answer is a powerful process that acts like a gatekeeper. It's designed to catch these exact kinds of problems before they become a catastrophe, and it's called the first article inspection, or FAI. So what is it exactly? At its core, FAI is a formal, structured way to prove that your manufacturing process can actually build what your engineers designed. It's a super detailed comparison of a real part from your production line against every single design requirement. And here's the key takeaway. FAI isn't about inspecting every part that rolls off the line. No, it's about validating the process that makes the parts. That very first part, the first article, serves as the proof. It's that critical quality gate that makes sure any problems with your tools, your materials, or your methods get fixed before you hit the big green button on a full production run. All right, so how does this quality gate actually work? What are the tools and the steps you need to follow to do a proper FAI? Well, everything kicks off with a blueprint, but not just any old blueprint. For a first article inspection, you need a special, carefully prepared document called a ballooned drawing. The idea here is actually pretty brilliant in its simplicity. You see all those circled numbers? Each one of those, called a balloon, is like a unique serial number for a single design feature. It could be a dimension, a tolerance, a note about the material, anything that has to be checked. This turns the drawing into a crystal clear, easy-to-follow checklist for the entire inspection. So you've got this drawing with all these balloons. Where does all that data actually go? It gets carefully logged into a formal document called a First Article Inspection Report, or FAIR. And if you're in the aerospace or defense industry, this pretty much always means using the industry standard AS9102 format. Now, that AS9102 report can look a little intimidating at first glance, but really, it just breaks down into three logical forms. First, you identify the part. Second, you verify all your materials and special processes. And third, you record every single measurement. That's it. Let's look at Form 1. This is all about part accountability. Think of it as the part's birth certificate. What's its name? Its part number? What's the latest revision level? If it's an assembly, you list all the smaller pieces here too. It creates a perfect chain of traceability right from the get-go. Next up is Form 2, which is all about product accountability. This is where you prove you use the right ingredients. You'll attach things like material certifications, logs from heat treatments, or specs for special coatings. It's the hard evidence that you used the right stuff and you did the right things to it. And finally, we get to Form 3. This is the real heart of the report. This is where every single one of those balloon numbers from the drawing gets its own line. You write down the requirement, you record the actual measured result, you note which tool you used, and then you give it a clear pass or fail. So if we zoom out, the whole FAI workflow looks something like this. You pre-plan and gather all your documents. You create your inspection plan with that balloon drawing. You actually manufacture a sample part from a real production run. You collect all the data, and then you compile everything into that final report. Okay, this process is obviously incredibly detailed. It's a lot of work, so you don't need to do a full FAI every single time you make something. So what are the specific triggers that tell you, yep, it's time for one? Generally, you're going to need an FAI for any brand new part or a major design change. It's also triggered by big changes to your process. We're talking new tools, moving to a different factory, or even just using a new supplier. And here's a big one. If a part hasn't been made for 2 years or more, you have to do a new FAI to prove the process still works. Now, you can imagine in industries like aerospace and defense, the stakes are just sky high. A single failure is not an option. That's why in those fields, FAI isn't just a good idea, it is an absolute requirement. Now, something that often trips people up is the difference between FAI and another process you might have heard of called PPAP, which is huge in the automotive world. The easiest way to think about it is that FAI is basically one piece of the bigger PPAP puzzle. FAI is laser-focused on just 1 to 5 parts to make sure they match the drawing. PPAP is much, much broader. It's about proving your entire system can handle high-volume manufacturing for the long haul. So after all this meticulous work, the ballooning, the measuring, all the documentation, what's the real reward? Why do the best manufacturers invest so much time and energy into this process? Well, the benefits are just massive. You slash your costs from scrap and rework by catching problems super early. You get solid proof that your manufacturing process actually works. You make sure you're compliant with tough industry standards. And maybe the most important thing of all, you build bulletproof confidence with your customer by giving them hard evidence that you can deliver exactly what you promised. Which brings up a really important question. I mean, this all sounds great when everything goes according to plan. But what happens when a part fails the inspection? And this is the beauty of it. A failure isn't a disaster. It actually means the system is working perfectly. When a part fails, production stops immediately. A non-conformance report is filed, the team figures out the root cause and fixes it, and then a new FAI is performed to prove the fix worked. It's a closed-loop system. No shortcuts, no guesswork. You know, FAI has been the bedrock of quality for decades. But as we move into this wild new era of smart factories and fully automated production lines, you have to wonder, how is this very human-led process of verification going to evolve? What does the quality gatekeeper of the future even look like? That's exactly the kind of question we love to explore here at NextGen Manufacturing Nexus. Thanks for watching.